Hello everyone. In the last video, we have solved Z transformation of some standard sequences. That is Z transformation of a power n, Z transformation of n, n square, n cube, etc. Today, I am going to solve some more problems on properties of Z transformation. We have linearity property in Z transformation. So what is linearity property? It is Z transformation of A into un plus or minus B into Vn equals A into Z transformation of un plus or minus B into Z transformation of Vn. Here A and B are constants and un and Vn are discrete sequences. Next, we have damping rule. We have damping rule here. What is damping rule? If Z transformation of un equals u bar z, then Z transformation of a power minus n into un equals u bar into a into z or az. And second one, Z transformation of a power n into un equals u bar of z by a. I am not going to solve these two properties now, that is linearity property and damping rule, because in the syllabus they have mentioned only problems on these two properties. So I will move on to some problems. Then how can we use damping rule? In the last class we have solved Z transformation of n, that is Z divided by Z minus 1 whole square. For example, if they has to find Z transformation of a power n into n, then we need to replace z by a here. That is Z transformation of n is z divided by z minus 1 whole square. Then if we apply a power n into n here, then we need to replace z by a. Then we get z by a divided by z by a minus 1 whole square. Then we get z by a divided by, if I take LCM, we will get z minus a whole square divided by a square. This a cancel, this a goes to numerator, that is Z transformation of a power n into n is az divided by z minus a whole square. This is by using damping rule. Similarly, if they have mentioned a power minus n into n, then we need to replace z by z into a or a into z. Similarly, if they ask to find k power n into n square, to prove k power n into n square, then solution. First we need to write Z transformation of n square. What is Z transformation of n square? It is z square plus z divided by z minus 1 whole cube. Z transformation of k power n into n square, then we need to apply z square plus z z minus 1 whole cube. We need to apply z in the place of z by a by using this damping rule. So here they have given k, so replace z by k. If they are mentioned to find k power minus n, then we need to replace z by z into k. So what happens if we replace z by k? So this becomes z square by k square plus z by k overall divided by z by k minus 1 whole cube. If we take LCM, we'll get k square, so this becomes z square plus z into k overall divided by z minus k whole cube divided by k cube. So k square k cube will remain with k. This k goes to numerator, and after multiplying this k to inside, we'll get k into z square plus k square z divided by z minus k whole cube. So this is the z transformation of k power n into n square. Similarly, we can find k power n into n cube. If they have mentioned in the place of k like e power an, then replace k by e power a here, that is e power a z square plus e power 2a z divided by z minus e power a whole cube. Similarly, if they are mentioned 2, then replace k by 2 like that. Okay, we'll move on to the next question, that is prove that z transformation of cos n theta is z into z minus cos theta divided by z square minus 2z cos theta plus 1, and second one, z transformation of sin n theta, it is z sin theta divided by z square minus 2z cos theta plus 1. And these two problems are very much important. We can see these two questions in so many university question papers. Okay. So how to solve z transformation of cos n theta and sin n theta? We can solve these two means cos n theta and sin n theta simultaneously. For that, we need to know the formula of e power minus in theta. I can write this e power minus in theta as cos n theta minus I into sin n theta. Similarly, if I have e power plus in theta, then cos n theta plus I into sin n theta. First, I'll try to find z transformation of e power minus in theta. I can write this as z transformation of e power minus I theta whole power n. It is in the form of z transformation of a power n. What is z transformation of a power n? It is z divided by z minus a. Similarly, I can write the z transformation of e power minus I theta power n as z divided by z minus e power minus I theta. Here replace a by e power minus I theta. Next, multiply z minus e power I theta and divide z minus e power I theta. If I cancel these two things, will remain with the same thing. So nothing will change if I multiply and divide by z into e power minus I theta. Next. So multiply this, we'll get z into z minus e power I theta divided by z minus e power minus I theta into z minus e power I theta. I can write this as z into z minus. So e power I theta means cos theta plus I into sin theta divided by, multiply these two things, we'll get z into z, z square, z into this minus z into e power I theta, and z into this minus z into e power minus I theta. Next, minus into minus plus, we'll get e power I theta into e power minus I theta. So we'll get a power m into a power n, it is a power m plus n, that is e power I theta minus I theta is 0, e power 0 is 1. So directly I can write this as 1. Next, z minus cos theta minus I sin theta divided by z square minus z into, if I take minus z common, we'll get e power I theta plus e power minus I theta plus 1. E power I theta plus e power minus I theta means 2 into cos theta. So z into z minus cos theta minus I sin theta divided by z square minus 2z cos theta plus 1. That is, if I multiply and divide by 2, we'll get, so this is the formula for cos theta. In the left side we have z transformation of e power minus in theta. I can write this as, this e power minus n theta as cos n theta minus I into sin n theta equals this answer. Here also separate the real and imaginary terms like this. So real terms are z into z minus cos theta minus I into, multiply this z to inside, minus I z sin theta overall divided by z square minus 2z cos theta plus 1. By comparing the real and imaginary terms, we will get z transformation of cos n theta as the real term z into z minus cos theta divided by z square minus 2z cos theta plus 1. Similarly, z transformation of sin n theta equals z sin theta, here imaginary term, z sin theta z square minus 2z cos theta plus 1. So this is the z transformation of cos n theta and sin n theta. In some university question paper, they have asked to find z transformation of a power n into cos n theta. Similarly, z transformation of a power n into sin n theta. So we can solve this by using damping rule. By using damping rule, we can write z transformation of a power n into un as u bar of z by a. So for this we already know the z transformation of cos n theta. We have cos n theta, that is z into z minus cos theta divided by z square minus 2z cos theta plus 1. For this, if we apply a power n, then replace here z by a. So we'll get z by a minus cos theta divided by z square by a square minus 2z by a cos theta plus 1. If we take LCM, we'll get, that is z into z minus a into cos theta divided by a square overall divided by z square minus 2az cos theta plus a square overall divided by a square, and this a square and this a square will cancel with each other. So z transformation of a power n into cos n theta is z into z minus z minus a into cos theta divided by z square minus 2az cos theta plus a square. So this is the z transformation of a power n cos n theta. Similarly, we can find the z transformation of a power n into sin n theta. So what is z transformation of a power n into sin n theta? So like this, by changing z by a, we can find the z transformation of a power n into sin n theta. We have z transformation of sin n theta as z sin theta divided by z square minus 2z cos theta plus 1. Replace z by a, will get z by a into sin theta divided by z square by a square minus 2z by a cos theta plus 1. So we'll get z sin theta by a. If I take LCM, it is a square z square minus 2az cos theta plus a square. On a and this a square will cancel, will remain with a. This goes to numerator. Finally, the solution is z a sin theta divided by z square minus 2az cos theta plus a square. So this is the z transformation for a power n into sin n theta. Then what is the z transformation of cos hyperbolic n theta and z transformation of sin hyperbolic n theta? We have a formula for cos hyperbolic theta, that is 1 by 2 into e power theta plus e power minus theta. So by applying that formula, we can write this cos hyperbolic n theta as e power n theta plus e power minus n theta divided by 2. So we need to find the z transformation of cos hyperbolic n theta 1 by 2 into z transformation of e power n theta plus e power minus n theta. I can write this e power n theta as e power theta power n and this e power minus n theta as e power minus theta power n. By applying the linearity property, I can write this as 1 by 2 into z transformation of e power theta power n plus z transformation of e power minus theta power n. It is in the form of z transformation of a power n. What is z transformation of a power n? It is z divided by z minus a. So by using that formula, I can write this as z divided by z minus e power theta. Similarly, plus z divided by z minus e power minus theta. By taking LCM, I can write this as, so take this z outside, we'll get z minus e power theta into z minus e power minus theta, cross multiply this, we'll get z minus e power minus theta plus z minus e power theta. We can write this as z by 2 into z plus z 2z. If I take minus common, we'll write e power theta plus e power minus theta divided by z into z, z square minus z into e power minus theta minus z into e power plus theta plus 1, e power minus theta into e power theta, that is e power 0 equals 1, like previous one. I can write this as z by 2 into 2z minus e power theta plus e power minus theta is 2 into cos hyperbolic theta, and this z square, take minus z common, will get e power minus theta plus 1. I can write this as also cos hyperbolic theta. So take 2 common, take these 2 common, this 2 and common 2 will get cancelled, will get z into z minus cos hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. So this is the z transformation of cos hyperbolic n theta. If they has to find z transformation of k power n into cos hyperbolic n theta, then by applying damping rule we can solve this, that is z, just replace z by k here, z by k minus cos hyperbolic theta divided by z square by k square minus 2z by k cos hyperbolic theta plus 1. So take k LCM, will get z into z minus k into cos hyperbolic theta divided by k square overall divided by z square minus 2z k cos hyperbolic theta plus k square overall divided by k square. So this k square will get cancelled. It is z into z minus k cos hyperbolic theta overall divided by z square minus 2zk cos hyperbolic theta plus k square. So this is the required result for z transformation of k power n into cos hyperbolic n theta. Similarly, we can find z transformation of sine hyperbolic n theta. So to find z transformation of sine hyperbolic n theta, just now we have solved z transformation of cos hyperbolic n theta. So I will directly go to z transformation part. I can solve this by taking z transformation of e power theta power n minus z transformation of e power minus theta power n. 1 by 2 into z transformation of e power theta power n is z minus e power theta minus z divided by z minus e power minus theta. So z outside will get 1 divided by z minus e power theta minus 1 divided by z minus e power theta, z by 2 into, if I take LCM, will get e power minus theta z minus e power minus theta, cross multiply this, z power minus e power minus theta minus z plus e power theta. Z minus z will get cancelled. So we will remain with z by 2 into e power theta minus e power minus theta overall divided by z square minus z into e power minus theta minus z into e power plus theta plus 1. I can write this as z into e power theta minus e power minus theta as sine hyperbolic theta by using that formula, and we have 2 and this 2 will get cancelled. We'll get z square minus 2z into cos hyperbolic theta plus 1 by using cos hyperbolic theta formula, e power theta plus e power minus theta divided by 2. So this is the z transformation for sine hyperbolic theta. Let's do some more problems on z transformation. So what is the z transformation of n plus 1 whole square? So it is in the form of a plus b whole square. So a plus b whole square means a square plus b square plus 2ab. So z transformation of n plus 1 whole square means z transformation of n square plus 1 plus 2n. By applying linearity property, we can write this as z transformation of n square plus z transformation of 1 plus 2 into z transformation of n. We have already proved the results for these three things. So I can write directly as z transformation of n square as z square plus z divided by z minus 1 whole cube, and z transformation of 1 as z divided by z minus 1 plus z transformation of n as 2n as 2 into z divided by z minus 1 whole square. Next one, z transformation of 3n minus 4 into sine n pi by 4 plus 5. Here z transformation of 3n means z transformation of 3n means 3 into z divided by z minus 1 whole square. We can write directly. Z transformation of 5. Here 5 is just constant. So it is nothing but 5 into z transformation of 1 power n. So I can write this as 5 into z divided by z minus 1. Remember, z transformation of 5 means it is nothing but constant. It is just like z transformation of a. If we have z transformation of 5 power n, then the answer will be z divided by z minus 5. Here we have only 5, so this 5 is constant. Take 5 outside, we will get z transformation of 1, that is z divided by z minus 1. So to solve this part, sine n pi by 4, first we should know what is the z transformation of sine n theta. What is z transformation of sine n theta? It is z sine theta divided by z square minus 2z cos theta plus 1. Here we have n pi by 4, we have theta, so replace theta by pi by 4. We will get z transformation of sine n pi by 4, that is z into sine pi by 4 sine 45 degree z square minus 2z into cos 45 degree plus 1, that is z into what is sine 45 degree? It is 1 by root 2 divided by z square minus 2z into again cos 45 degree is 1 by root 2 plus 1. If I take root 2 LCM, we will get z divided by root 2 z square minus 2z plus root 2. So by applying these three things, we can write the z transformation for this. The solution is 3z z minus 1 whole square minus 4 z divided by root 2 z square minus 2z plus root 2 plus 5z divided by z minus 1. So next problem, z transformation of sine 3n plus 5. It is in the form of sine of a plus b. What is sine of a plus b? It is sine a into cos b plus cos a into sine b. By applying that formula, we can write sine of 3n plus 5 as sine a into cos b, sine 3n into cos 5 plus cos a into sine b. It is cos 3n into cos 5. To find z transformation of sine of 3n plus 5, we can write cos 5 is constant, so take it outside. Z transformation of sine 3n plus, this is sine b, sine 5 into z transformation of cos 3n. So to solve sine 3n, first we should know what is z transformation of sine n theta. What is z transformation of sine theta? Just now we have written this z sine theta divided by z square minus 2z cos theta plus 1. So just replace theta by 3 here. Similarly for this one, write z transformation of cos n theta, that is z into z minus cos theta divided by z square minus 2z cos theta plus 1. Again replace theta by 3. So by replacing those things, finally we get cos 5 into z transformation of 3n. It is z sin 3 divided by z square minus 2z cos 3 plus 1 plus sin 5 into cos 3n, z into z minus cos 3 overall divided by z square minus 2z cos 3 plus 1. Next problem, z transformation of cos of n pi by 2 plus pi by 4. See here it is in the form of cos of a plus b. What is cos of a plus b? It is cos a into cos b minus sin a into sin b. By applying those formula, we can write this as cos of n pi by 2 plus pi by 4 as cos a into cos b. Cos of n pi by 2 into cos b, cos pi by 4, it is cos 45 degree. Cos 45 degree is 1 by root 2 minus sin a into sin b, sin n pi by 2 into sin pi by 4. So we know the value of sin pi by 4 also, it is 1 by root 2. By applying that, we can write this as 1 by root 2, 1 by root 2, 1 by root 2 take common, cos n pi by 2 minus sin n pi by 2. That is z transformation of cos n pi by 2 plus pi by 4. Finding of z transformation of cos n pi by 2 plus pi by 4 is nothing but finding of 1 by root 2 into z transformation of cos n pi by 2 minus z transformation of sin n pi by 2. Like previous problem, first we had to write z transformation of cos n theta. What is z transformation of cos n theta? It is z into z minus cos theta divided by z square minus 2z cos theta plus 1. Similarly, z transformation of sin n theta is z sin theta divided by z square minus 2z cos theta plus 1. So replace theta by pi by 2. If I replace theta by pi by 2, we will get cos of n pi by 2 as z minus, what is cos 90? It is 0. So 0 divided by z square minus, again cos 0 is 1, 0 into anything, sorry, again cos 90 is 0. So z square plus 1. Similarly, z into sin 90 is 1. So z divided by z square plus 1 because cos 90 is 0. So finally, this star becomes 1 by root 2 into z transformation of cos n pi by 2 is z square divided by z square plus 1 minus z transformation of sin n pi by 2 is z divided by z square plus 1. So we can take z square plus 1 as LCM. So 1 by root 2, it is z square plus 1 into z square minus z. So this is the required solution. Okay, try to solve these two problems. So it is z transformation of cos hyperbolic theta. It is in the form of cos hyperbolic theta. To solve this, use cos hyperbolic theta formula, that is e power theta plus e power minus theta divided by 2. Take e power theta common, then try to solve for e power I n theta by using z transformation of a power n formula. Similarly, for second one, it is n divided by 3 power n. Take this 3 power n to numerator, it is 3 power minus n into n. Apply damping rule. Z transformation of n, it is z divided by z minus 1 whole square. 3 power minus n means replace z by 3 into z. Damping rule, u bar z into a. So again apply damping rule for z transformation of n square, replace z by 2, and directly you can write the z transformation of cos n theta formula. 4 power n, it is nothing but z divided by z minus 4, and z transformation of 8 is constant, that is 8 into z divided by z minus 1. Thank you.